Hello, good morning, good afternoon, good evening, depending on where you are watching it from. In this video, we'll be using integration by part to solve a particular problem in calculus. But before we do so, why can't we just pray to our God? Let us just ask for retentive memory and more understanding. Let's use 2 seconds to pray. We are in prayers. Amen. Okay. Love you guys. Yeah. I'll be using integration by parts to evaluate this function. But before we do so, if today is your first time of meeting me here, go to Google, type Remjoc Maths. You will see, amen, Remjoc Maths. You will see a lot of solved mathematical problems. Not only solve mathematical problems, you will see comprehensive lecture notes for those who are preparing for WAEC, JAM, ND, HND, BSc, MSc, up to PhD level. You will see comprehensive lecture notes, mathematics comprehensive lecture notes there. Please make sure you share this video. Try and help somebody. Then you can also follow me on Facebook. Type this Remjoc Maths. You will see me. Join my Facebook. Follow me. My Facebook page. You will see Remjoc Maths Class 2. Just join that class too. It will help you. If you have any mathematical problem, please don't hesitate. As long as you are my followers, I will make sure do my best to solve that problem for you. Is that clear? Make sure you invite others to follow me and share this video. Thank you and God bless you. Okay, now we want to look at this idiot, this problem. You know, when we're in school, students always complain of dy all over the x. It's very difficult. I have to correct you that it's the simplest course so far, as long as mathematics is concerned. Dy all over the x is the simplest but simplest. Okay, so we are to integrate this function, integral x squared in x dx. Amen. It's simple as ABC. We are going to use integration by parts. We now say integration by part using either by part or integration by part, whichever one. Using by parts, amen, by parts, it means the formula is u dv is equals to uv minus integral v du. This is the formula. So now, yes, we can now say as it is, if we want to equate it with this one, if we solve it, we might not arrive at the real answer, but I want to tell us that instead of u to be this, you say let u be in x. Let u be equals to in x, and your dv be equals to x squared dx. dv be equals to x squared dx. Yes. Okay. So now we are going to differentiate this with respect to x, integrate this with respect to x, then substitute it into the formula. That is what we are going to do. So it means our du all over dx is going to give us 1 all over x. If you differentiate in x, it will always give you what? 1 all over x. But if you integrate 1 all over x, it will always give you in x. Take note. Okay? Then our du will now be equals to 1 all over x dx. Take note. Then let us integrate both sides. If we integrate the v, we are going to have v So here will be v equals to, if you integrate x raised to the power 2 dx, it's going to give you what? X raised to the power of 2 plus 1 all over what? 2 plus 1. Please don't put constants because we are using by part. Is that clear? So it's not necessary. You put constant here. Constant will be attached after integrating the function finally. Okay? So here will now be v is equals to x raised to the power of 3 all over 3. Okay? So now we are going to substitute it here. If we substitute it here, this is equals to ordinary v is what? Our ordinary v is in x, then our ordinary u is in x, ordinary v is x raised to the power 3 all over x raised to the power 3 all over 3. Then what we have here minus integral v, our ordinary v is x raised to the power of 3 all over 3 dot du is 1 all over x dx, true or false? Okay, so if you agree with me, are you seeing what I am saying? Okay, so now, yeah, as it is, if you have in x times x raised to the power of 3 all over 3, please, for the sake of Malians, I know Malians want to write it this way, and this is the same thing as in x raised to the power of 4 all over 3. You are wrong, please, mathematically. Is that clear? Please, you are wrong. Are you following? Just like you have sine x times x raised to the power of 3 all over 3. You cannot write sine x. This cannot be equals to. You cannot write it this way. It cannot be equals to sine x raised to the power of 4 all over 3. You are wrong. Please take notes. Is that clear? So what I'm trying to say is this. What I'm trying to say, if you are using index to multiply this, you put it this way. X raised to the power 3 all over 3 times in x. This is the right form. Like the other one too, sine x times x raised to the power 3 all over 3. This, the right form is x raised to the power 3 all over 3 times sine x. This is the right way. Please take note. Is that clear? So here, if you can see what I am saying, amen. If you can see what I am saying, this is equals to x raised to the power of 3 all over 3 in x minus integral. You don't need the prophet to tell you this and this will go. True or false? So we are going to have x raised to the power 2 all over 3 dx, isn't it? So if you can see what I am saying, amen. So here we can write it this way. We can write this idiot this way. Note that if we have x raised to the power of 2 all over 3, this is the same thing as 1 all over 3 dot x raised to the power 2. True or false? Please take note. So if you agree with me, here will now be, because I want to do something, that is why we can x raised to the power 3 all over 3 in x minus, it means here we can factor out 1 all over 3. True or false? 1 all over 3 will be outside the integral. Then we are going to have x raised to the power of what? 2 dx. Amen? So it means we are going to integrate this function. So if we integrate this function, x raised to the power of 3 all over 3 in x minus 1 all over 3. If we integrate this, we are going to have x raised to the power 2 plus 1 all over 2 plus 1. Then we can now add the constant, either b or c, but let it be capital letter. So now here will now be x raised to the power of 3 all over 3 in x minus 1 all over 3 dot x raised to the power of 3. 2 plus is 3 plus the constant. Amen. So if you can see what I am saying, what is common here? 1 all over, that is x raised to the power 3. All over 3 is common, two of us. So we can factor it out. So x raised to the power of 3 all over 3 is common. Open bracket in x minus 1 all over 3 close bracket plus b. Yeah, because by the time you factor out this, you still get back this idiot. So this is how you are going to integrate this type of function. So should in case you come across this in JAM anywhere, this is how you are going to integrate it. Thank you and God bless you. But don't forget to share this video. See you in the next video. Bye. Bye bye.